So, in this session, we will see about the image formation by both concave and convex lens. So, concave mirror and convex mirror. Concave mirror is otherwise called as the converging mirror. So, what is meant by converging? So, as we have previously described, concave mirror will be in shape of the cave, which is bent inwards. And this is my principal axis. On the principal axis lies your pole. The point near your mirror is the pole, and there is a focus and the center of curvature or the radius of curvature. So suppose if this is the object we have placed, and there will be many light passing from the object. So these are my incident light. Alright, towards the mirror is the incident light. So once the light hits the mirror surface, it will all be reflected back. So these are my reflected light. So when you notice in the concave mirror, all the rays are returning back at a particular point. So all the rays are getting converged. So converge is nothing but the reflected rays are getting concentrated at one point, or they are joining at some point. So converging is nothing but joining. So whereas you see in your convex type of mirrors, so here the principal axis lies on the opposite side. So here will be your pole, here it is the focus, and here it will be your center of curvature. So this is the object we have placed. Always we will place the object on the left side of your mirror, right? So these are the incident light. So all the light, when it hits the surface of the mirror, they all get reflected back. So this is my reflected light. When you see here, the reflected light does not join together. They are getting dispersed or diverged. So this is your diverging mirror. Convex mirror is your diverging mirror. Diverging is nothing but getting separated. Okay. Now let us see how the image formation is by both of the mirrors. So first let us talk about the concave mirror. As I have told you, concave mirror is the converging mirror. So on the left hand side of my screen, you can see the tabular column provided in your book. So how the nature of the image and the position of the image and the size of the image, how it will be depending on the position of your object. So concave mirror is nothing but the converging mirror. Converging mirror. So there are some 4 cases we have to discuss here depending on the position of the object and the reflected rays. So depending on the position of your object, your reflected rays will also differ. Alright. So this is my concave mirror. Concave mirror is always bent inwards. This is my pole. This is my focus. And this is my center of curvature. And as we have discussed, PC is R and F is equal to R by 2, or R is nothing but 2F. This we have already discussed, right? Okay. Now let us talk about the first case. So irrespective of the object, now I'm going to talk about the image formation. Alright. Suppose I'm placing my image, placing my object here. I'm placing my object here. This is the object A, B. Alright. So it is beyond C. My object is beyond C. So there will be n number of rays, n number of light from the object. From the object, there will be n number of light rays hitting your mirror. If suppose the light ray, I'm considering the light ray hitting parallel to the principal axis. So which is my principal axis? Which is my principal axis? This line, no? The line where you have drawn your center of curvature, focus and pole. This is your principal axis. N number of rays will be hitting from the object onto your mirror. So first I'm considering an incident light which is parallel to your principal axis. Parallel means it will not intersect your principal axis at any point. That is parallel. So how will my reflected ray will be? So if your incident light is parallel to your principal axis, then your reflected light will pass through the focus. It will pass through the focus. This is case 1. Case 1. Incident light is parallel to your principal axis. So how will your reflected light be? Reflected light passes through the focus. This is my case 1. So let us consider case 2. Case 2. Same, we are having a principal axis, the mirror. This is my pole, focus and center of curvature. I'm having the object here. Okay, the object here. So from this object, I'm considering the incident light passing through the focus. Passing through the focus. This is my incident light. So how will my reflected ray be? Your reflected ray will be parallel to your principal axis. Parallel to your principal axis. So see the difference. In first, your incident light was parallel to the principal axis. So my reflected light was passing through the focus. Here, my incident light was passing through the focus, but the reflected light is parallel to your principal axis. So incident light is passing through the focus. The reflected ray is parallel to your principal axis. Now I am considering the case 3. In case 3, same, you are having a mirror, a principal axis, pole, focus and center of curvature. Now I am talking about, this is my object, AB is the object. I am talking about a ray passing through the center of curvature. So let this be center of curvature. My incident light is passing through the center of curvature. This is my incident light. So the reflected light will retrace the path, which means this is my reflected ray. The path where it hits the mirror surface, through the same path it gets reflected back. So in this case, your incident light and the reflected light all pass through the center of curvature. If your incident light passes through the center of curvature, the reflected light will also retrace the same path. This is case 4. Now I'm talking about case 3. Case 4, I'm going to talk about a point where, see, this is my pole, focus and center of curvature. Now my incident light is obliquely hitting the mirror. So near the mirror, which part of the principal axis lies? Yes, the pole. So my incident light from the object AB, it hits the pole directly. So this is my incident light. So how my reflected ray will be? It makes the same angle with your principal axis. So angle I is equal to angle R. So that is your law of reflection, right? That is the law of reflection. If a normal, the incident ray, a normal to the mirror and the reflected ray all lie on the same line. And the angle of incidence is equal to the angle of reflection. That is the law of reflection, and this also obeys your laws of reflection. So the normal is your principal axis here. So the incident line and the reflected line and your normal, they all lie on the same plane, and the angle of incidence is equal to the angle of reflection. This is your laws of reflection, right? So these are the 4 cases we have seen, and I hope you could all see the image here. So if you place the object at infinity, the position of the image will be at the focus, and the size of the image will be highly diminished and point size. Diminished is nothing but it will be very much minimized. A smaller image of the object you will see in a point size. And how the nature of the image will be? It will be real and inverted. Okay. So I will tell you the difference between real and inverted in the next video clipping. You just see to it. You see, if you keep the object beyond C, that is beyond the center of curvature, the position of the image will be formed in between F and C, and the size of the image will be diminished, that it will be smaller, but not as small as when the object is at infinity. It will be smaller, and it is also real and inverted. At C, if you keep, you will obtain the same size of the object. The image will be same size of the object, and it will also be real and inverted. If you keep the object between C and F, uh, the position of the image will be beyond C. It will be beyond C, and it will be enlarged. It will be in higher size, magnified, and it will be real and inverted. At F, if you keep, the position of the image will be at infinity, and the size of the image will be highly enlarged and real and inverted. Between P and F, uh, you could actually see the position of the object behind the mirror. Behind the mirror, we call the space to be virtual. Only before the mirror, you can see the real image. Behind the mirror, when we are talking, there we can see only the virtual image. And as such, it is enlarged and it is virtual and direct. Thank you.